In this video, we are going to talk more about terminating and repeating decimals. So in our previous lesson, we looked at, so I'm trying to focus my camera and talk at the same time. Okay, so sorry. So in our previous video, we were talking about taking a fraction and converting it into a decimal. So in this video, we're doing the opposite. What if we start with a decimal and then we convert it back into a fraction? So remember, there are two different types of decimals. We have terminating decimals and repeating decimals. So the terminating ones are the easy ones to do because we can write a fraction just based off of the place value. So if we look at, we are on page 257, so just continuing on with what we were doing in the last video. We want to change each of these to a simplified fraction, show the fraction that is retrieved directly from the decimal before simplifying. Okay, so the first one is 0.46, so just think about what that means. That is 46 hundredths. So this one would be 46 hundredths. So 46 divided by 100. So just taking it out to the place value. And since we're supposed to simplify this fraction, let's see, what does this divide into? So let's see, you can take out a 2. So that would be 23 fiftieths. And then I think that's all you can do with that one. For number 2, 13.037 would be 13 and, this would be 37 tens, hundreds, thousandths. So 37 thousandths. And I don't believe that simplifies. So I think that's just going to stay. I think 37 is prime. Let me just check really quickly. Yeah, so it's not going to simplify. Number 3. So you'll notice that I've scribbled out the negative signs. So we're not going to worry about negatives. We've never talked about negative numbers before. So 2.006 would be 2. And then you would have 6 tens, hundreds, thousandths. So let's see, that would reduce if you took a 2 out. That would be 3 500ths. I think that's as far as that one simplifies. Number 4, 29 tens, hundreds, thousands, 10,000ths. So 29 10,000ths. That one is probably already simplified. 18.380. So let's see, this would be 18 and. So you can think of this in a few different ways. You could say this is 380 tens, hundreds, thousandths. Or you may notice that since the 0 is on the end, it doesn't necessarily matter. So this could also be 38 hundredths. And then if we keep going, let's see. 38 hundredths, if you take out a 2, that's 19 fiftieths. So 18 and 19 fiftieths. And then number 6, again, ignore the negative. So 37, and you could view this as 40 tens, hundreds, thousandths. Or again, the 0 doesn't really matter on the end, so that would be 4 hundredths. And if we want to keep reducing, you could divide by 2. That would be 2 fiftieths. So 37 and 2 fiftieths. Okay, so like I said, those are the easy ones. So the harder ones are changing repeating decimals back into fractions. So we are going to use the algebraic method to do this. Okay, and then again, I have ignored the negative, so I scribbled out the negative on number 9. And then there are negatives on 13 and 15. So you can just ignore those also. All right. So some of these you may be able to remember from the previous video when we talked about patterns involving dividing by like 9s, place values of 9s and 1s or 11s. So for example, this first one should look familiar, 0.5555555. It's a 5 repeating and it's only repeating once. So this one should be 5/9. However, if you don't remember that, that is perfectly okay. There is an algebraic method in order to solve these. So the big question is 0.555 repeating is equal to some fraction, right? So in math class, what do we call stuff we don't know? Usually we call it x. So there is some fraction out there that has a decimal of 0.5555555. All right. So in using the algebraic method, we want to create new equations based off of powers of 10, and we want to be able to create two equations that have the exact same decimal so that they will cancel themselves out. So remember, again, in the last video, we talked about moving the decimal place, and we actually in the last video moved it to the left. So how do you move a decimal place to the right to create a new number? Well, before, when you move it to the left, you divide by 10. So moving it to the right, you would multiply by 10. So whatever this mystery fraction is, if I multiply it by 10, then it's going to move the decimal and give us a new number of 5.55555. All right. So then now, therefore, we have two equations that have identical decimals. So we can use elimination in order to cancel those repeating decimals out. So I'm going to subtract. Now, I'm going to subtract kind of backwards, and I'm going to go in reverse. Otherwise, if you do up and down, like top to bottom, you're going to have a negative and then another negative. So it's just easier if you go in reverse. So not traditionally how you do things, but just trying to save some time. So 10x minus 1x would leave you with 9x's. And then 5.5 repeating. If you subtract off the 0.5 repeating, all you are left with is 5. So then if you solve for x, divide both sides by 9, you will get the answer. The mystery fraction is 5/9, which is, again, what I said earlier if you remember those rules. All right, so there's number 7. I was going to say number 1, but it's number 7. Let's try number 8. So there is some mystery fraction that is going to be 2.09 repeating. So 0909090909. All right. So again, maybe you remember our rule. We have 09s repeating. So that would be 9/99, which reduces down to be 1/11. So this will be equivalent to 2 1/11. But again, if you don't remember that, let's do some equations. So next equation, multiply by 10. So a power of 10 moves the decimal place. So we would now be at 20.9090990. All right, do those two have the exact same decimal? So if we tried to subtract them right now, what is going to happen? So let me just show you what would happen. So 20.9090990 minus 2.0909090909. If we subtract right now, we still have a decimal left. Okay, so subtracting these two is not going to help us in any way. So we have to keep going. What if we multiplied this new equation by another power of 10? So we'd be up to 100. Multiplying another power of 10 is going to move the decimal place once again, and now we would be at 209.09090909. Okay, now do we have two equations that have the same decimal? Yes. So x has a 0.09 repeating, and 100x has a 0.09 repeating. So we can kind of disregard this middle fact and just use the two that have identical decimals and subtract them so that the decimal will go away. So again, we're doing this in reverse. So 100x minus 1x leaves you with 99x's. And then 209.09 repeating minus 2.09 repeating. Decimals cancel. 209 minus 2 is just 207. Okay, so Sorry, my mind went blank for a second. Okay, so we divide by 99. So we have x equals 207 divided by 99. Okay. So I was trying to simplify it in my head before I was ready to. So 207 divided by 99 would be, if you wanted to reduce, again, 2. So 99 times 2, that would be 198. So that would still leave you with 9 on the top, which reduces down to be 2 and 1/11. Okay. So on your test or quiz next week, you can leave, I guess it's your test next week, you can leave your answer unsimplified, because I'm just happy you got the answer. So if you want to simplify, that is perfectly fine. But you can leave it like it is. All right, what about number 9? Well, there's two number 9s, so let's look at the first number 9. 0.583838383838. So this one, we're not going to be able to use our rules of 9 or 11, unfortunately. So again, there's some fraction out there that is 0.5838383883 repeating. All right. So we want to make two equations, have the same decimal so they cancel out. So start by multiplying by 10. Multiplying by 10 is going to move that decimal to the right. So that will be 5.838383. And we do not have two identical decimals, so we have to keep going. So multiply another power of 10. So that would be 58.383838. Now we have a decimal that's a 0.5, a 0.8, and a 0.3. So we still don't have two that are the same. So we have to go again. So another power of 10 would get us up to 1,000. That's going to move the decimal again. So now we would have 583.838383. All right, so now finally 10x has a 0.83 repeating and 1000x has a 0.83 repeating. So we can kind of disregard those two that we're not going to use. And if we want to subtract to find the difference, so 1000 x's minus 10 x's leaves us with 990 x's. And then 583.83 repeating minus 5.83 repeating is, let's see, 583 minus 5, 578 with no decimal. So divide both sides by 990. And your fraction should be 578 out of 990. And I don't know if that reduces. Let's see, you could divide this by 2, I guess. So that would be 289, 495, and then beyond that, I'm not sure. So let's just leave it at that because I don't want to spend time trying to figure out what that is. All right, so there's our answer, original answer. And then the other number 9, this is 0.4 repeating, so 0.44444444. So again, if you remember your trick about dividing by 9s, you should remember this is 4/9. If you don't, x is 0.4 repeating. So multiply by 10, that turns it into 4.4 repeating. So those have the same exact decimal, so 10x minus 1x is 9x. 4.4 repeating minus the 4 repeating is just 4. So divide both sides by 9, so your fraction should be 4/9. So just like I said, if you remember the rule. All right, so there are 6 more of these on the back. So why don't you take a few minutes and try these on your own. So pause the video, and then when you are done, unpause the video, and then you can check your work. Okay, so for number 10, some fraction is equal to 0.916 repeating, so just the 6 is repeating. Okay. So multiply by 10 gives you 9.16 repeating. We don't have two of the same decimal, so another power of 10 would be 91.6 repeating. Still don't have three decimals that are the same, so go one more time at least. That would bring us to 916.6 repeating. So now we do have two that have the same decimal, the 0.6 repeating. So let's ignore the two that don't matter. So 100x minus 100x would be 900x, and then 916.6 repeating minus 91.6 repeating should be 825. So divide by 900. So our fraction should be 825 divided by 900. Okay. So again, since I don't care about reducing, I'm not going to try to reduce. Obviously 5 would go into that, so it would reduce, but for the sake of time, we're just going to say it's 825 out of 900. Number 11. So there's some fraction that is 7.61616161. Okay, so 10 times that would be 76.16161616. Two decimals are not the same, so keep going. So 100x is 761.61616161. Now we have a 0.61 repeating and a 0.61 repeating, so we can actually stop. So this one, 100x minus x is 99x, and 761 divided by 7, or sorry, not divided by, 761 minus 7 is 754. So divide by 99, and this one should be 754 divided by 99. Also, which I haven't suggested yet, is that you should always check your answer. So if you're not sure if you did it right, just type that fraction into your calculator to see if you really get the decimal you're supposed to. So here's, for example, this one. So 754 divided by 99 is 7.61616161. Okay, so you can always check your work. If it doesn't come out to be the same thing, then you know that you made a mistake somewhere. So, and this is one you probably could have figured out. So this one would reduce down to, since it was 6-1 repeated, this would be 61/99. So 7 and 61/99 is what that would reduce to. So if you remembered your rules. Number 12, this is 0.066666666 repeating. So this is like one of the challenge ones. So 0.6 repeating would be 6/9. So with the 0, if we tack on a 0 to the denominator, this will end up being 6/90. But to prove that, multiply by 10, so that would give us just 0.6 repeating. We still have two different decimals, so go again. So that would be 6.6 repeating. So now we have the two with the same decimal, so we can ignore the first one. So 100x minus 10x would be 90x, and then 6.6 repeating minus the 6 repeating is just 6. So this one is 6/90. So that would be, 2/30, so a 15th. If you fully reduce, if you wanted to. That one is easy to reduce in your head. So, okay, number 13. Again, ignore this negative. 3.86. So 3.8 with the 6 repeating. So 10x would be 38.6 repeating. Those do not have the same decimal, so we keep going. 100x would be 386.6 repeating. Okay, so now we have 2 with the same decimal. So 100x minus 10x is 90x. And let's see, 386.6 repeating minus 38.6 repeating should be 348. So divide by 90 to get x by itself. So this one is 348 90ths. So 348 90ths. And again, if you just wanted to check, so 3.86 repeating. So we have the right answer. And then that reduces a little bit by 3. All right, 14. So here's another one that maybe you could figure out on your own. So it's 0.083838383. So if it were just 0.83, then that would be 83/99ths. So to get that 0, add a 0. So this one should be 83/990ths. But if you don't know that, that's fine. So move the decimal. So this would be 0.83838383. So we're going to go again. That would be 8.38383383. So still don't have 2 with the same decimal, so go again. Now we'd be at 83.838383 repeating. So now we do have 2. So let's see. It's this one and this one. So the 1000x and the 10x. So 1000x minus 10x would be 990. And then 83.83 repeating minus the 0.83 repeating just leaves you with 83. So x will be 83 out of 990. Okay. And then the last one, 4.72 repeating. So 4.72727272. So again, maybe you remember this, since it's 72, this would be 72 divided by 99. Or this is a power of 9, or a factor of 9, a multiple of 9, I should say. So this could also be 8/11ths. So 72/99 should reduce down to be 8/11ths. So 4 and 72/99, or 4 and 8/11ths should be our final answer. But again, if you don't remember, use algebra. So 10x would be 47.272727. Repeating, not the same decimal, so go again. 100x is 472.727272 repeating. And let's see, we have a 0.72 and a 0.72. Okay, so 100x minus x is 99x. And 472.72 repeating minus 4.72 repeating would be 468. So that would be 468 divided by 99. So that is perfectly fine. Again, if you wanted to reduce, let's see here, that would be the 4, and let's see, oops, 99 times 4 is 396, so from 468 should be the 72 out of 99. So if you remember the rule. Okay, so again, just like in the last video, there is no specific homework related to this. However, on your exam next week, I will give you some sort of decimal and ask you to convert it back into a fraction. So study these examples, or just make up your own. Make up some sort of repeating decimal, practice, see if you get the fraction, and then check that fraction in your calculator to see if it is the original thing that you thought of. So if you have any questions about converting decimals back into fractions, let me know.